Hello everyone, my name is Dennis and I'm the author of Chromatone.center, the website and the visual music language to learn, explore and express with. So the website is not just static pages, it's a very reactive and very interactive piece of software, because you can just start playing just your keyboard or connect a MIDI keyboard, so it will react to your MIDI, or you can activate the microphone input and just analyze the audio and see the notes. And yeah, this is quite nice, and this is just the front page. And if you dive into it, so you have theory, practice, shop, academy, support and contact sections. And yeah, this is how it all happens. So it starts as an experiment for me. It all started as an experiment for me. Then it got into the practice, then it got some theory into it, and then it evolved into this whole and holistic, musical system. But yeah, I will show you some very useful tools for musicians, so you can just see your spectrogram with colors of each frequency, so you can analyze your sound or any instrument or any composition, but you don't get too hard. So yeah, this is quite professional and ready to use tool, but some are not that finished and some are just barely started, and these have home in the experiment section. So here lives this synth that can just play you some weird noises, weird sounds with these commands, and I'm not very proficient with that. It was quite an experiment, and yeah, this is an experimental step till then. The new thing is Chuck, that won't work in Firefox but should work in Chrome. Let's just take a look at this, if Chuck will work. So I will be happy about this experiment that it's still running. No, it doesn't work even in Chrome, but yeah, it somehow loads on some occasions. Yeah, no problem. Oh, it's ready on Firefox. Just look at this. it has and it's loaded here too. So yeah, we can listen to some weird programs written in this Czech language. And yeah, so you can see that I'm exploring different ways to use web technologies basically, and even here we have some sessions in like a very early stages, and jam sessions, and all this is just experiments. And this is how I just grab technology from the web and try to implement it on my resources, so then we can elaborate on that and just build real tools. So once that spectrogram was just a library that outputted some FFT data, and then I found out, I can find the frequencies of each of them, and then we can map them. And yeah, there is a plenty of real world stuff going on in the Chromatone. And so let's dive into code. And I just want to show you the basic structure, because today we're not just fixing some bugs, but I've had some fixed there and moved a bit some content around. Yeah, let's see this amazing new thing. So elementary audio, this is quite a big thing for me. So is a JavaScript framework for writing high performance native audio applications. Wow, I like this. I want to use this. And here's quite a motivation, and there's this again some language to speak, and there is examples of web app examples, and yeah, there should be some inspiration for us to build upon. So we have app.js. What's that? So yeah, it uses WebRender and LM Audio Core and some helper functions and some canvas. Okay, yeah, so this looks quite playable. Let's look at it. So click or tap to start. Nice reverb. Very nice. Ooh. Yeah, that's impressive. Okay, GitHub elementary no controls, no more controls. Okay, if we let's have it playing in the background, and yeah, let's explore how we can elaborate on this. So this is just first time I'm trying to code anything with elementary, and yeah, this is the moment when I want to share with you. So I just opened the VS Code with this Git repository there. So yeah, there is Git repos, so you can find it in contact section, and here is this Git repo Chromatone center, and I just open it and go into the code. So we have the code, and there are layers, and main things are in use. So this is like business logic, so we deal with tempo theory, like music theory, colors, keyboard, MIDI, different things that will be visualized, but they are just logic going on, audio logic and all that. So eventually, if things go well, they end up in use section, and then it goes into this package, so you can use it from npm. So use Chromatone version 2.1. Yeah, it will just give you all this power just into lib. So yeah, this is quite a big JS file that has all this code for you. So export it. Many things, you know, MIDI and audio reactive apps just from one import. That's very useful. And also there's this theme, completely custom theme for the website. I made it by myself, gradually evolving the WordPress theme, and yeah, it starts in this content. Content is the main thing, and yeah, there's the DBs with some YAML information, components that are audio imported, so you can just forget about it, and there that are used in multiple places throughout the app, and the content. And the content is what you have here in this navigation. And what is the navigation? So academy, yeah, so these are contact, practice, public, shop, yeah, and we go to practice, yeah, and experiments, and then there are all the experiments, and I'm gonna start one new experiment, and I'm gonna just create a folder, so it will be elementary, as we are interested in that, and we'll create an index.md file. So this is our page, and it will have a title, elementary audio. Then we have a description, which is good for SEO. This will be like new audio lib experiment for now, just and date. I like to put dates, so I can sort by the dates. And it is 23rd, or it is June 23rd. Yeah, this is what we have now. We have a basic page with almost nothing there, so we'll call it elementary. Single top level headings in this multiple. Okay, so we will have not top level heading. Yeah, this is the page, and then I just press this button that is a made by extension for the VS Code, but I can just type in npm run dev, and we have, yeah, so vitpress dev is the npm run dev, this is the command, and then we have the server running. So this is the vitpress. Yeah, it got parsed all the libs, everything, and now we can proceed with this version of website. So it will be our development section. Let me make my camera a little smaller so you can see everything in real time. Yeah, so okay, we have this dev server, so we should go to experiments, elementary audio. Yeah, here it is. So here's our head and nothing more. And what we need next, we wanna build a view component for this. So this will be lm, lm audio, just lm. Okay, let's lm audio dot view, and there is just our view script. I use Pog. I hope you like it, and Uno CSS, which is just the same as Tailwind, but more open source, more fun to use, you know, lighter and faster. Okay, so for now we just need some container that will have just a background color, dark BG, dark 200, and let's have a shadow to it. It's just for fun, and rounded corners. And then we can have our let's say just before elementary inside here. So this is how it's gradually built. So here we need a script setup. I can auto import this, just putting it into the components folder, but I like to have like clear structure, so anyone can just open this and see what's going on and see from where we grab all that. And yeah, I don't have autocomplete in Markdown, but I don't need much because I just need lm audio, yeah, like this, and yeah, we got our oh yes, the path should be like this. So now we should see our block with elementary inside. So we can just remove this heading and have the experiment running just here. Yeah, so there is our script right there, and we can get have some fun with it. So let's go out to our package.json and look at our script. So we need I've installed these two, so lm audio core and also lm audio web render, and this is how their examples are built. And yeah, so let's look at the structure and making sound 101. But yeah, we need to see the web render, because yeah, web render, yeah, so this should be, yeah, this is just the most basic stuff. let's go into it. So we can close this and go here. So EL, this goes fine. Audio context, core, web render. So on load we have these two. So we will have two notes, and I don't want to hear that loud note, so let's do it like 220. Number of main node, core, initialize, node connect. Yeah, so yeah, we initialize audio, and I don't know if this can run without user input, but let's see. So no audio playing now, and yeah, I'm not sure if it gets blocked because there was no user input behind this. Now it plays. Yeah, I don't hear two waves. Let's put it like this. Yeah, definitely hear. I like the hot reload, guys. You hear that? Yeah, I just don't know how to stop it for now. Yeah, just don't go there for now. So I open. We get this nice 110 in the right ear, 220 in the left. So yes, I like it. So this happens on load, and I want to connect this to my MIDI setup inside of my Chromatone.center website. And now this comes to reading all this documentation. This is what everyone likes most, and there is a plenty of documentation, topics discussed there, and I'm just want to jump into this understanding keys. Maybe I can understand keys from there. So if your only ever makes a single chord, then this section won't. In such case, will in-depth dynamic behavior. Yes, happens when you make multiple successive calls. Simple synthesizer. Yes, so we have voices, we have a synth. Let's just add some VS. VS should be voice from here. So we set frequencies. So on MIDI we can have this MIDI information. Function E, voices and E. So I can process MIDI just right there. It's another thing to explore, but yeah, let's look at it. So we have this main that runs just in the setup, but we are in the Vue.js environment. So best thing is to have this on mounted. Let's be verbose. So okay, I will go and import on mounted from Vue. This is not the only thing that we will import, but now it's the thing that we need. On mounted, and we have this function, so it will run this code on mounted but not on this moment. I like this, and it should be async. Are only within allowed. Yes, now we are allowed. Then I think these things should all happen on mounted. So CTX and core are all on the web happening all on the web, not on the client, in the browser, not on the server when we build that. So yeah, that happens on load, on mounted. I think this should go just fine. Open, get the node, and I think there should be a stop thing that we can maybe turn off the render, but it's not quite transparent to me, and I want to address this thing to the authors maybe of this library, because still it's kind of making the DSP much easier. But I'm a complete novice in this, even after years of development, my web apps. So web apps are just around all this, deep level complex stuff. And this looks quite easy to implement if you know what's happening inside with all this audio. And if you don't know, you want to use something at first, like synth that is already MIDI reactive, and I hope and I believe there is one. So I've just found it in examples maybe, but now we're just researching and making a like I'm showing you the development process. And so now we will comment out this line and won't have this crazy sounds coming into our ears. And we will just go into this into this example, understanding keys, and here is what's happening. So we will have on load MIDI, and we have update voices and the synth. So let's grab the synth. I like it. So but synth should be here. Yeah. Function. Why is it wrong? Let add one bracket more. Yeah, so this is synth and update voices. We don't have this still. We don't have this, but yeah, this is synth, but we need update voices, and it's function update voices. And this will just EV, so we will have the MIDI event here. Let's call it EV here too. So MIDI event will go here, and we won't produce any sound now, but let's just console log the EV. And now we open our page, but we need to go to Chrome, of course, because MIDI on Firefox is still not just there. But I need MIDI, not just keyboard. Yeah. So let's see. I have yeah, I should have my new Playtronica devices here. Yeah, so here it is. So we will see our MIDI there and listen to it and explore it together. So here we can just connect it. One moment. Yeah, so here's the touch me, and it will give us some notes in MIDI, and we have to connect it to the computer. And there we go. Yeah, the lights are there, and we get the MIDI data. Touch me, yes. So if we just turn on MIDI synth and refresh the page, maybe it should be working somehow, but it doesn't. Sync tabs, MIDI, PC keyboard. Let's check the main site. Yeah, so MIDI synth. Yeah, it's working there. So we have some complications just only on this side. MIDI options. Now let's look at the main page. Yeah, let's load it back again in another tab. No success. Sync tabs, clock out, MIDI synth. So we can see. Yeah, we are filtering. We are filtering toggle all. Yeah, now we see the colors. Yeah, we are filtering the MIDI. So yeah, these are the notes played, and with this we can just go to our practice experiments, elementary audio, and hopefully get some information from the console. But no information is coming through. So voices, because voices are nothing here. Yeah, so now we should see some console log. Why not? Onload. Let's see if we put no. Yeah, I don't understand this situation. Let's just console log EV just right there. So issues, but no console log. And if I just console log the core, let's console log on here. Loaded. So yes, we have loaded, but on MIDI doesn't produce any data for us. That's a pity. That's not very good, and it doesn't. We don't see any installing MIDI event handler in the load. Fired any incoming from the connected and the argument. Yeah, voices, actual implementation is omitted. So not much MIDI information, but let's go to core and okay, let's go to audio effects plugin. Wow. So web app examples is what we are into, and just open it with GitHub desktop, and we will experiment on that too. So yeah, let's go to, let's put it right, no, not right there, but into Chromatone, and web examples is fine. Okay, clone. Hope you like this random music being played. I like its spaciousness. Okay, so they don't have. Yeah, they have this HTML star open with live server. So let's hear that. But they don't have. Oh, this is planets. Not. These are not MIDI examples. Okay, maybe we can see it in the main web examples. Yeah, this was planets. Yeah, so elementary API reference. So these are the circles you go through, you know, when you're exploring new things, and you should feel like you're not knowing anything and you're not right, and then you will get all the data, all the information, like from the source and not from your ideas, because then it gets even more confusing. I cannot find this events thing, so where should set elementary grid, tone grid synth made with elementary, tone grid synth made with elementary. Sounds pretty fine. Yeah. I like this. This sounds very nice, and this was the thing that influenced me when I was looking through this library. Microtuning additive synthesizer, you know? What? I hope I can use the code from there. Get started. Wow. Does it produce sound from MIDI too? No. Elementary audio source chords, harmonics. All of the harmonics are there. Tuning system and keyboard. Now I can hear it. Yeah. ED5. Yeah, it's just a deep rabbit hole, but it reacts to keyboard events. So I like this system. I can go just to maybe lib, maybe controllers, keyboard, yes, and MIDI also. So MIDI, key down, event emitter. This is all implemented in view use. I don't need to go dive into this, but yeah, or in MIDI nodes. So yeah, this is how I built it too. So everything goes to MIDI interface, and then web MIDI could not be web MIDI. So they don't use the internal on MIDI. They use just web MIDI. Yeah, that's how I do it. And index is just play and stop. Node event map. So there should be MIDI inputs set, add listener, connected, disconnected, web input, MIDI inputs set, get input names, MIDI inputs set disabled. Yeah, so we have this node emitter, play stop. Yeah, enable is just initiation, get input, and disable. So yeah, we just bind to synth. And let's look at the additive synth. And no, maybe audio. Yeah, controllers. Yes, this looks to, yeah, web render, core. Yeah, this should be the main thing to have. Yeah, so additive synth is loaded here, tuning is loaded here, audio store and event emitter. Yeah, so this should be the place where all this happens. So yeah, we have audio store update. Yeah, so this is context. If no context, yeah, so this synth class initializing itself. On load, audio store update element ready true. So where we load, we somehow update the store, and the store is just get audio store, like Svelte store. Yeah, so we have like data in Svelte coming into like some storage of sound and maybe some samples, as I can understand. Okay, start, pause, play note. This is important. So MIDI note element ready. So update voices is here, slice -8. So we have they just add voices and then drop them. Okay, I just start to grab this, and then there's this stop note. What's interesting is render additive synth, and or if yes, so we render some new information coming from this additive synth that is built on the voices, and then if voices are all over, there's no voices, active voices now, we put a constant silence into the render function. Okay, so as I understand from now, we have this render going on always, and if we update something there, it will render what we put into. So we should stack everything just before the render and then use it to put it there. Okay, I kind of get the idea. I need to find all this information about this L const. What is this silence? Where is this key silence coming from? But yeah, it looks fine, and this is the main function. So, oh, sorry, you don't see it right there. So let's look at it closer. Take a closer look. Yeah. So MIDI, and we have voices and a MIDI note, which is a number. Then we have this key V MIDI note. Okay. Then we have tune. What is tune? It comes from tuning. Yeah, so we get the frequency for this. Yeah, I have this function. So console log, MIDI note, frequency. Okay. Then voices filter. Then we filter the voices, and if voice key is not key, so this V, for example, V60, you know, like the C note, yeah, A note. Okay, if it is, so concat gate frequency and key and gate. So we always get voices that will have this information. Ooh, that's where it gets complex to me. Yeah. Oh, and render is just not core render. It's another render. So ensemble number or node, and it gets core from audio store. I will definitely go to the audio store and have this core, and DC block out. I don't understand. Ensemble DC block gain out multiplied by 3. Isn't that much? Okay, and gain out is going out. Yeah, this is not that easy, you know, and even reading all this code is just, I'm just deep into some open source code, not documentation, and this is not obvious, and this is a long journey, you know, so this music can go long a long time, and we will just be reading and trying to find how to make this, because yeah, this is export const, this is the synth that takes voices and draw bars. Yeah, these are just getting data, and then we filter the gains, we filter partials, and then add voices, and for each voice we create a node, additive voice. You see that? It's the rabbit hole, it goes and goes and goes. So additive voice is a whole lot of DSP going on. Yeah, that's add first partial map, and then it somehow returns another, and there another. Wow, guys, that, so key is voice key gate. Why do we need this key? What does this do for us? So it's like how we can control element const value. So seems like this is the address of like a voice or the node that we can put a new value to. So we can put frequency multiplied by partial. Yeah, should be real thing. Element cycle with a const, what does this mean? These are very interesting questions, and yeah, this seems like we are not very fast to implement some sounds, but let's try with this more simple one. So they tell that we will have this voices. This is okay. Let's do it. So let's think about like having this synth running, and okay, so MIDI doesn't work. This is okay for us, no problem at all. In example, we are not starting with MIDI. We will start with so we have to update voices, and when something happens, yeah, we will say core render synth. So okay, for example, as I can understand this, I can just say yeah, we can just oh sorry, to restart the view server I need the MIDI. I need to import MIDI. It doesn't look allows is allows true. Yes, I don't know why don't I have this autocomplete. Okay, let's go into it. So import let's say use MIDI. From this will be just use MIDI like this, and we can have this MIDI object from use MIDI, and you can have it in your app too. So this is MIDI object, and yeah, we can just watch, and we also want to import this watch from view, and we will watch for the MIDI note, I believe, and say note will be console logged note. Yes, so let's run it. We have this loaded, and then if I play note, we will say note. Seems like it's better to say note value as we are consoling. No, it doesn't work. It's still. Oh, and we are not on the page, and this runs only when we are on the elementary audio page. Yeah, so here we see. Okay, why? Yeah, this should be value, and if we stay on the page, no, this is undefined. Okay, but the properties of this target are these, and there is this number. So note number will give us the output. The output for. Oh my god. Experiments elementary. Yeah. So here we go. Yeah, this is MIDI. And we can react to it. And we need elementary reactions to it. So hope that understanding keys will give us this understanding. So render X, render Y, synth, voice. Okay. We have the synth. Let's have the voices, but it should be a ref. I think. Like const voices equals ref from view. Now we have the autocomplete from somewhere. So voices are these, and they have gain 0, frequency 440. And okay, we will have this synth, and yeah, the synth is there. And when we have this update, so we have update voices here, and we will say update voices. We can say voices, and I don't need voices to set just right there. We just be there as a ref, and I just need to have. So let's check what does this function do. So maybe we don't need it at out. So we omit the actual, but we can imagine here that such would look at, and if it is note event, we update one of the voices of our array to set its gate to 1 and its frequency to E note frequency. Perhaps in such a case our resulting voices array would look like this. And similarly, you can sort the voices object to set the appropriate voice gate value back to 0. Yeah. No, now after updating, but I can have more. I maybe have. Yeah, I already have my MIDI, so we can check. We can watch MIDI active notes like this, and if we just play our keyboard right there, so right now, yeah, so I have this reactive object that is outputting the note, the MIDI number, and also the velocity. So we can have all this data there. We already have it, and this means that we can just go with that deeper. So what is the synth doing? So synth gets what? It gets V gate and V frequency. Yes, so gate and frequency, this is what we need to put there. But gate, I like the velocity section. So velocity, yeah. So voices will be computed. It's not compressed, not compact. Let's have it like this. So it is a computed function. Where are the voices, ref? Okay, yeah, so, and it will be a map. So we can see that in my demo we have an object, but there we will update voices, and then how do we, so this can run this on this watch. We can watch active notes, yeah, and do things here. So let's say notes. This is notes. Maybe not notes. Let's set it as a list. Okay, and we will make a computed. No, we will watch and render reacting to this. Yeah. So what can it be? So we can go and for each voice. So for each note, let's take just n. No, I think first we will have to make this new computed, and then so let's say this voices is this computed. Yeah, we will need this voices there. Okay, voices is a computed that returns. So we will go over the object keys of MIDI active notes and map over them. So we will have our note number, and we can just say that okay, we will but now I can just modify active notes. Yeah, so I can modify the synth. So it will it returns with a function which returns so let me make it a little more easy for me to read. We don't have a this word here, so we can be safe with arrow functions. And okay, let's continue. Now we will map over them and create this and output these objects with velocity set to MIDI active notes with N, and also frequency set to pitch frequency. Yes, we load it for the pitch, and yeah, we just need a pitch, and this should be just N pitch frequency, just for maybe a middle A number. No, this is octave. Let me check. So I can use calculations and have this MIDI color pitch. Pitch note octave. MIDI color pitch frequency. Pitch color frequency pitch. So I can just let's check this like it is now. Pitch frequency. So if we go to the example here, so let's put it like text to Excel. Let's make it bigger, and let's say it font mono, and we will output our voices. Now if we open it, yeah, this is our frequencies. 400 1400. It's too much. Okay, for now let's check it like this. So 440, and yeah, around this. So if yeah, this is but minus 30. Yeah, let's minus 69, I believe, will be our quite okay system. Yeah, so this is 440 and this is red color. Yeah. So velocity and frequency, we got this voices, and we can just watch them and have a synth do the job, I believe. Let's go back and update voices and core dot render synth and on MIDI and voices, just synth list, and also synth list should be fine, should work for us. I wonder if it will. Okay, reference core is not defined. Okay, okay, yeah, so let's have it there on watch, and yeah, let's put I think it will be fine. Elementary audio loaded. Oh no, we have some new errors. Yeah, DOM exception, post mesh unsupported type of structured. Okay, we should have like velocity and V velocity and V frequency. Oh no, I'm out of battery now. Running off battery. Sorry. Yeah, but that's better. We have some errors displayed. I'm reloading to see this error. Okay. Unhandled error. So it was run 2 times. Oscillator class. Was unsupported type of structured data. Unsupported type of structured data, synth and list. But we synth list, and synth has voices. And voices is quite nice. Velocity is 1 and frequency is a number. Velocity is so voices multiplied and cycle v frequency. Fric is just the information that it's going there. No, post unsupported type of structured data. Let's see, maybe voices we are. Let's console log maybe. The list. I don't know. This is what I can do for now. So this is array of objects, and synth just goes. Let's put the synth yeah, inside here. I don't know, maybe it will go better. So vs voices, then we map over them and multiply v velocity. And okay, let's have a gain back. Maybe I was wrong by setting this gain. I don't have any ideas for now. How can I fix that? Core render synth list. Let's say one of them. Let's call out this synth list. What does it do for us? Component is null. Yeah, what component? Component is null. Because we don't write anything there. So now we should have no component. Which component? V gain and vs voices. Let's console log v from here. I just don't understand how it works just in JavaScript. So yeah, it outputted some stuff. So 38, we have the list, and the list is props array, some node, primitive, multiply, and an object. This is a whole lot of things to explore. And then what did they have there? Maybe it's just so gain will be made active nodes. Let's multiply it by 0.0 by 1.0. I don't know. And frequency, maybe no, it should be precise. Gain, MIDI, all that. Okay. I think we are getting. Oh, no errors for now. No errors. Yeah, that looks okay. Gain and symbol. Yeah, this should be working. Let's try to render it. And we have this weird post message, and yeah, this kind of this is kind of hard to investigate, you know, because it's so deep. Somewhere into some workers, you know. I'm not sure that issues will come off right there, so I can let's say unsupported. No, this is a rabbit hole that goes somewhere deep. But okay, let's think about being even more easy with that. So there was this examples and web app examples, just not examples, but making sound 101. So audio processing, core, render. So let's check this out. So if voices, like say if list length more than 0, so we will say this tone and render this, okay, and it should run on our key press. Sine tone, and what is sine tone? And this is the sine tone, okay. Okay, let's explore this. Reload the page. Component is null. Expecting a node type here got undefined. But I'm not doing anything, you know. I'm just rendering. So we should hear the sound. Yeah, so core render is doing this job. Oh no. This wasn't just hung there, you know. Oh guys, this is a long story. Can you believe that? Even turning off the browser. Okay, it was running, yeah, in Google Chrome. Yeah, that's kind of weird stuff happening, and I'm not sure if I will be quite successful, yeah, with implementing this, but I really hope so. That's why this video is all about. That's why I'm making this video, and this is about implementing some nice new tools, and yeah, it gets complicated a bit, but no problem, we can go through this with our console logs. We can do everything. Cannot read emits options and violations and all that. So maybe if I can just core render, okay, no sine tone, no everything, no anything. So when I press a key, please render each time I press the key. Yes, okay. The hello world is there, you know. Now I need to put silence, yeah, so like set timeout, and set a function there, and set timeout to 2 seconds, and let's score that render. What it was like, I remember, where was it? It was in the synth, additive synth, on note off. Stop note is render al const, like this. So this is how we stop sounds from coming. Okay, so okay, I hope to see. I'm refreshing just to have the output clean. So yeah, yes, it's playing only one note, and I like it. So let's have let's just stay there in the watch function and just try to do this clear. So now I feel confident of setting the frequency, getting it out of getting it from yeah, so I will be implementing my own synthesizer from this point. So this is quite fun and complex. I think I need, at this moment, I need to draw some schemes, but let's have just a basic thing. So let's say it's monophonic, okay? So let's have an if, and we will stop. Yeah, so if list length is greater than 0, so we will have this render, crazy render with 2 sine waves. Let's put it 440 to have some fun. Let's put it, yeah, 440. And so else there are no voices playing, so we will put this constant there. So this should make us play this weird synth. It doesn't care about our list. It only plays one note, but we already have its frequency. So if we just console log this list.0, we will always have and I'm playing synth list. What do we have this synth? Function is here. So I don't need this synth. I will create my own synth. Yeah, I will just work from here. So I will just console log the first note of the list. Yeah, and we have the frequency. So if we just go and say let f just is list that 0 dot frequency, so we can say cycle f, and we have our monophonic synth. Wow! I'm happy to hear that. Yeah, really, this is how it works, just gradually grasping. This is not AI, this is just, basic biologic AI, that is intelligence, BI, that is learning to some new stuff. So, new audio lib experiment. I can play notes, and I can. Yeah, this is very nice. Next, I will publish it like this. Yeah, because my main goal is to build some web apps that will work for many people all over the world, and I need to bundle it, and for it I need to test it. I need to test it on different devices, and with this I can just connect a MIDI keyboard wirelessly or with a wire to my iPad, iPhone, or other devices, and test the sound. Test if the sound is fine, if there are no clicks and all that, because with Amy I got into clicks, I got into some audio sampling frequency problems, and yeah, it was dark, and now we're using this modern elementary audio, and yeah, the build seems to go fine. It's kind of long one because yeah, we have so many components all around, and all the pages need to build. But yeah, eventually we will see that it took about 150 seconds. 60 seconds, because we're running this here. So I can serve that just to check the build. I prefer to do that just to see if browsing is. Yeah, it's fine. So we can just deploy this, and yeah, it's not that hard to deploy from local computer. I built some pipeline for the site to build just on GitHub Actions, but I don't care whichever method is best. I use both. So what we have today, we have a working monophonic synth that is built on top of elementary audio. I will test the sound on different devices and try to build more. And yeah, I think one thing we need to do about this is to go maybe to the main page, find some. Okay, maybe save this image as, and put some image into this content. So this experiment is a new content, and it's in a practice experiments elementary. So lookup SVG. Okay, maybe they have some resources, tutorials. Yeah, elementary. I like this. Right, I like this thumbnail. So I can save maybe this page. I can let's just grab this image and open again our elementary HQ default. So I will grab this name and have this cover moment. Yeah, so there it is. So experiments, it should, yeah, it just displays there. Maybe it's not best picture. Maybe we can find better, some white and bright. Core library in I don't know, maybe that SVG will be fine. Reveal in Finder, lookup. Oh yeah, so lookup SVG will be fine. Lookup.svg, yeah, should go there. Yeah, yeah, it shows logo. Yeah, it's SVG, so should be wow, It still have some pixels. Okay. Yeah. I just want to think with you and maybe have a task, for all of us to think about how to make this polyphonic, that then we can just grow and grow and grow and grow. And yeah, I think one important thing is to just move out of this component, and yeah, let's do it for just 10 minutes. Maybe I will be finished with that. So let's see, use lm synth dot ts. So use lm synth ts will do that all inside. So let's put it like this, and then we will say that we export function use lm synth with some data maybe coming in, but the main thing, we will return all the refs, all the computers that we want. And okay, for now we are there. We are inside this function, and on mounted there are many things happening, but we return voices for our current render. And node connect, we don't return anything more. Yeah, we just need to use element synth. So we missed one line there. Okay, one line there. And here we can say import use lm synth from just nearby, use lm synth that just this, and we will say const voices use lm synth like this. So page reloads, and we still have all this complex data happening just there in this component, basically view component, but nothing to deal with. All the logics is here, and we can extract that and have this monophonic synth just right there in the use. But still, I want to keep everything compact while I'm building, while I'm experimenting. Everything will be very fluent, but yeah, I like that when working from these composable functions, you still get all the reactivity you want. So let's check this out. So so this voices is very important to us, so we can just control the parameters of our render cycle, because here yeah, I believe there is this add function that can help us to do everything fine. So let's open it and go into understanding keys. Maybe we will try to understand. So elementary add, and then we will have a an array which will return a multiply of v gate and v frequency. So this should be fine, it should work for us. Let's establish this synth maybe right there, and find which, and yeah, let's simplify it again. So like this, and then we have this map, and then we have this add, and yeah, we don't need this return. I don't like this. This is not needed at this moment, and this should look a little more clear to understand. And even like this, maybe even cleaner ES5 style, you know, synthesizer. Okay, we almost there. Total, but found. Okay. Synth, const, of course. Const synth equals like this. We do it like this. VS. Yeah. So this should work. And let's just render it just right there. So we will have like synth, and we will have list 0. So yeah, it should work just the same, like this. So let's try it. Okay, no, cannot emits options. This same error happening for us. But these are voices. Maybe we have problems with this proxy happening. So let's go back to this setup. This should be running nice. Okay, first thing is we can just explore only this section, so multiply. I don't care if no, first thing is let's try to have a let C is this cycle of F. I just wonder if it will be viable to set this C and C. Okay, this works. Now we have this multiply, and let's try. So we will multiply the frequency, and so okay, so this is our first frequency, yeah, and this is cycle, but so we will have this multiply by gate of this same thing. So dot gate, and have it closed like this. So gate is our problem. Reading key. So multiply is the problem, but if we multiply by 1, and if we multiply by 0.3, yes, it is still not too loud, but we don't need this gate, we need the velocity. So so voices, we can just watch for, no, we can just watch MIDI active notes, I think. Yeah, we should, if we are working on this synth, and this watch will be our like main function, so we can have this function, this action, happening here, and we can say that this is a list. Okay, the list is right there, and notes, active notes are here. So we will just go through the active notes and have the list. Okay, so now we don't have these voices export here. We don't need this export here. We just have a use element synth like this, and yeah, we have the watch source can only be getter effector. Okay. Yes, so we watch like this, and this should, yeah, we still have all the notes, and now we can just so do we need it like this? No, we will have to go just, and for each note, no, yeah, so having this list is fine. It's fine. So if it is like this, we can go maybe gain cannot, no, gain can be 1. Console log. Okay, so now we can just have a list. Let's console log list.gain. Property voices, it is no problem. We don't need voices right now. So it's 1. So if I just put it there, should work. But it is 0.3 still. Now it's 1. Now it's louder. Okay, so MIDI-synth is working in some other tab, I believe. Okay, the polyphonics. Okay, so now we have this thing happening. So this C is putting everything there. Now we should think about making it a sum. So if I just L add and close the brackets, will this, yeah, this should still works. So, and if I put an array there, will it work too? No, it doesn't work. But if so, this will be just a list. So if I add 1, no, it's not correct. Add 1 is not correct. Okay, it will be lconst. Yeah, I understand. So we can add. So this will be just the sum of all. So we can go through them. So we can go through. So we can say that our sum, our sum is the list map. So we go through each voice, and what do we do for them? We say that We do for them this. So we will have this. We will have So we will have this add and we will have it like this. So okay, so now I will have many map. Okay, so we map over them, and we have this for each of them, and then we can play this sum. But I'm still playing, and just need to say it like, let it be this V frequency and this V gain. Yeah? No? V frequency and V gain. I deleted something. So V frequency and V gain. Boom. This. Yes. This is monophonic with. Yeah, this goes over the top because we just add up things, and I will need to explore how to make this limited and compressed and distorted and reverberated and delayed and all that. So this is quite inspiring, really, because we have this function that returns nothing, and it just plays us some sound. So I can just plug and play this into my website and it will just work. I'm very eager to test it on my website, and let me try it on my iPad. So I can go to Chromatone Center, and hopefully their experiments are already there. Yeah, elementary audio experiment is there, and the only thing I wanna do is to plug in some MIDI controller and go to web MIDI browser. Web MIDI browser is there. So HTTPS and sorry for the delay, but there is HTTPS Chromatone.center. Okay, and then we go to practice, experiments, elementary audio, and do we hear any audio? No, I don't hear any audio right now, but yeah, it thinks like I have some phones. Okay, let's do it. I will try it right there. Oh yes. Yes, can you believe that? Can you believe that? I have all the audio coming through. I have this crazy sound, loud and still monophonic in web version, but it's polyphonic on our present experiment page. Yeah, this is there is a room to optimize that and make it more transparent, and I need to establish some controls for this, so there definitely will be some returns, and we can do all that. So I'm just going and going and going with that. It's not just, you know, like you are just always getting stuck with this. No, it's just a very, very interesting exploration going on, and I think we will make some very nice experiments and proper web apps and some nice tools for you to use for your music. Let's just have one thing. Let's have just one control for this synth. I don't know which one. Maybe the volume. So we will have a constant that will be called something like options, like LM options, LM opts, like this, and it will be a reactive object. I will import it from view, reactive object, and I need to restart these servers for some. Yeah, so this is LM options. Where's the error? Where's the error? Where's the error? Left hand side is pitch frequency. We don't know. Yeah, let's say number. It will be more transparent and more reliable. Okay. So options will be like, okay, volume, and let's say it will be 1 for now. But then we can just return these LM ops. Let's say options, and now we can have it right there. So this vgate is should be also multiplied by our LM options dot volume. Yes, and then we return these LM options, and this still works fine, and we will have this const LM options equal, yeah, and we can just display it in a pre, for example, LM options, but that's not very interesting, you know, for us. LM options, yeah, volume, but we can use something like let me check. So in components we can control or other, no, rotary, I believe it's rotary, and it can be in the theme. There are so many. Yeah, control rotary, this control rotary, yeah, it is what it is. You can set minimum, maximum, model value, step. So let's have a step set to 0.1, v model set to LM options dot volume, and what else? Maximum will be just 1, and step and unit will be nothing, and the param will be just vol like this. So we don't have this multiplication going on. Maybe it's fixing this. Yeah, this is another thing to explore, because frequency and gain, and if so watch, and then we have this multiple, and where is, oh, the synth is not used here. We don't need this synth function. We have our new synth function. Okay, and gain, yes, so here. Let's refresh, I hope. Yes. Yes, we have our control, and this means that we can just do many things, and with the reactive interface. And yeah, now I was changing, the firing of the note. Maybe we can just go and change the volume precisely inside, while running this, and this can be controlled, by gain added after this whole setup. So after this sum, so I believe, if let's say it should be kind of result, so L will have like gain, no, will be like multiply. Yeah, will be like multiply. At first there will be a sum, and the second will be this volume, and we will have the result there, and now if we check this out, of course, we are changing this. We are reacting to the active notes, but we should be reacting to the change in the volume. So when the volume changes, we should change the function there. So this can be achieved if we have this as a watch effect. Oh, this can be dangerous, when you go into this watch effect territory. Oh, you can easily create very nice loops, feedback loops, and it will just be running and running and running forever. But let's check. Yes, we have it. We have this reactive change, and it reacts to active notes. It reacts to whatever we put here. So active notes is the basic thing, but once we have this LM options volume here, it will react to our LM options volume. I don't think that we need this fast. Maybe we should debounce this. Yeah, I like this. And maybe the last thing to put in will be just having this gain just divided by the list length. Maybe this can just work for us from there. Yes, it works. yeah, maybe I will kind of divide it with some function that should go into this. I don't know, maybe EL something, and will be more precise, because this is just linear decrease in gain, but we need some maybe exponential for it to have like be proper. I know, maybe there is a convenience function, maybe there is a whole lot more, the big layer of functions above, but I don't know. I will explore that and I will share my experimentation right there. And if you interested in something like this, you can go along with me, because when I'm experimenting, I try to put links just there into this markdown file, and have all this information just right there, so it will be easily accessible when I next get back to these examples and working with this. So I don't need all these open tabs stored there. Yeah, so yeah, this is elementary audio, this is Chromatone, this is my experimentation with all these technologies, and hope you like the development process, hope you like the product that is happening for us, because yeah, I think that it is important not only to play music and understand how it is constructed, but also construct your own instruments, music instruments for yourself, like how you feel it, how you know it. And this is like my big music instrument for you, not only to play, but learn, explore, and express with. So yeah, hope you like this, and if you have any questions, you can put them in the comments section, and stay tuned for more. See ya. Bye.